Hello, my name is Miri. I'm a postdoc at Stanford University, advised by experts in the areas of affective science, computer science, and neuroscience. I take a multidisciplinary approach to design, build, and evaluate vibrotactile technologies aimed at facilitating affect regulation in general population and soon in the vulnerable population of children diagnosed with autism spectrum disorder. Before I begin, I'd like to define two terms that I'll be using throughout the talk. First one is affect. Think of affect as an umbrella term for emotion, mood, and stress. The second one is affect regulation. Consider affect regulation as things that we do to cognitively or behaviorally alter affective states that we judge to be unwanted or context inappropriate. In this talk, I will cover my paper PIV++ accepted by CHI 2020. For now, I'll ask you to take my word that we built a vibrotactile breathing pacer to guide users through conscious, slow-paced breathing. We took a data-driven approach to place the tactors on users' abdomen and created a robust personalization procedure to ensure that the vibrations are easily noticeable, are dual-phasic, and are easy to synchronize breathing with. By dual-phasic, I mean the inhalation and exhalation phases of the vibrations feel significantly different from each other. PIV++ is a registered study in which we examine the causal effect of the pacer and anxiety reduction in presence of a cognitive stressor. We had 100 participants randomly assigned to treatment and control group while balancing for the gender. 3 participants were excluded because of the procedural error. After excluding these, we had 97 participants, 44 in the treatment group and 53 in the control, all balanced across gender. So based on our PIV paper, we use the abdomen for the placement, and we use this pattern of vibration that is frequency-based. You can see the 2 vibrations. The dual phasicness comes from 2 different frequencies. And of course, we had a personalization procedure. To establish a causal impact of the pacer, we deployed a mixed design experiment. Mixed design experiment is a powerful tool and should be used more often in evaluating efficacy of affect regulation technologies. It enables great statistical power that a between subject design would not be able to provide. And this is because the mixed design experiment addresses the threat to internal validity, which means that you can better rule out alternative explanation for an observed effect. So let's say some participants in a between subject design experiment were really good at affect regulation at cognitive level. And if they all happen to be in a treatment group, then they could drive an observed calming effect that is not even related to the intervention that we're studying. Mixed design experiment setup are not prone to such an effect. Second, it provides insight as to who, in terms of individual differences, would be more likely to benefit from the breathing pacer. For example, individuals low on Five Openness are more likely to benefit from the device than those higher in openness. If these individuals were in the treatment group and used the device, they experience a drop in anxiety, but if they were in control group, they didn't experience a change in their anxiety. Now, shifting back to the type of the stressor, we use Compound Remote Associated Task, CRA. CRA tasks ask participants to come up with a 4th word that completes a set of 3 seemingly unrelated words under a time limit. Here is an example: dock, fold, dollar, and the answer is bill. Dock bill, billfold, and dollar bill. Our mixed design experiment had 2 sets, and each set had 27 questions, CRA question, with each question taking about 9 seconds for a total of approximately 4 minutes per set. Notice that it was easy to use deception in the study by telling participants that we are interested in studying the link between creativity and haptics. Here is a flowchart of the study experimental design. All participants went through the same procedure until end of post-stressor 1. That is over here. At that point, participants who were randomly assigned to the control group went through block 2 while receiving no vibrations, over here, shown with solid line, while participants who were randomly assigned to the treatment group went through block 2 while receiving the vibrations. That is over here, shown with the vibrations. Block 1 contains of the first stressor and 2 waiting periods occurring before and after the stressor. So that is block 1, before and after. Waiting periods, called pre-stressor 1 and post-stressor 1, allow time to pass in between stressors so that the anxiety from the stressor would not affect measurements taken at other stages. All participants followed the same procedure from baseline up until the end of block 1. Right here. The structure of block 2 was identical to block 1. In addition to previously mentioned instructions, the treatment group saw the following additional instructions during pre-stressor 2. Please allow your breathing to conform with the sensation of the pacer if you can, whenever you can. Self-reported measure of affect, positive and negative, as well as state trait anxiety sticks were collected at all of these stages. We pre-registered 3 research questions, and we have shown that the pacer reduced anxiety but did not influence the positive and negative affect. Look at the top left figure. We observe an interaction effect between condition, post-stressor 1 to post-stressor 2, and group, treatment and control group, for the state trait anxiety score. And the effect size was 0.33 Cohen's-d. The results shows that the treatment group experienced a drop in anxiety from post-stressor 1 to post-stressor 2 compared to the control group. We ensure that from pre-stressor 1 to post-stressor 1, though, there is no interaction effect between condition and group. So the nodes being apart from each other at post-stressor 1 over here is not due to an effect, because till end of post-stressor 1, both groups went through the same procedure. We did not observe any interaction effect between condition, post-stressor 1 and post-stressor 2, and group, treatment and control group, for the positive affect, so over here, and for the negative affect, over there. Now let's shift gears and talk about our exploratory analysis to measure heterogeneous effects. The mixed design of our study provides us with an opportunity to examine what features of individual differences led to benefiting more from using the pacer. Notice that we found a causal effect of the device in lowering anxiety, and that finding could help us to further examine what type of individual differences contributed to this anxiety reduction. For example, if we were able to bin the data into 2 sets, for example, people low on reappraisal versus people high on reappraisal, people low on openness versus people high on openness, and then demonstrate that for one of the bins, we see an interaction effect, meaning if the participants are in the treatment group, they benefit from the device, there's a drop in anxiety, but if they're in the control group, they don't. And in the other bin, there is no effect, then we can say that people are more likely to benefit from the device if they are low on that feature, for example, openness, reappraisal, etc. And that is what we're going to talk about now. Our approach is for each feature of interest to identify the magnitude of a contribution of the feature to anxiety drop. If the magnitude is large enough, we then look at a cutoff value of that feature, which flips the contribution from drop in anxiety to no drop or even increase in anxiety. For the features with a higher contribution, we concluded further tests to examine whether the predicted drop in anxiety was due to use of the pacer, or whether the people with certain characteristics were already predisposed to see the drop regardless of use of the pacer. Here we see the magnitude of the feature contribution on the left and the direction of each feature contribution on the right. So the more spread out on the right, the larger the magnitude. Let's focus on the points on the right first. For each feature, these are the features, 32 Shapley values, each corresponding to an individual in the treatment group data, are distributed horizontally. We mentioned that the treatment group had 44 participants. Here we see 32, and the reason is because these 32 participants were in the training data when we were applying the XGBoost machine learning model. Let's walk through an example. Consider the top row. During study, stressor differentiate. It means how well did the participant differentiate between the inhalation and exhalation phases during post-stressor 2. And as we remember, 0 means very easy and 100 means extremely difficult. Each point represents an individual. The color of the points represent the value of that feature. The bluer points represent participants who could relatively easily differentiate between the two phases of the vibration pattern of the pacer, means values closer to 0, and the redder points represent participants who could not. So these are the people who had harder time differentiate between the vibrations. Now let's look at the x-axis. These are the Shapley values. The more negative the Shapley values, so the ones that are on the left side of this vertical line, the more that feature contributes to a drop in anxiety for that particular participant. The more the positive on the opposite side of the line, the more it contributed to anxiety not dropping or increasing. So this particular participant on the very left, who were able to differentiate between the inhalation-exhalation phases, had a drop in their anxiety. And this feature is a good predictor for the drop in anxiety. Now for this guy over here, they were not able to differentiate between the inhalation and exhalation phases easily. And so this feature did not contribute to the drop of the anxiety of that particular person. For the sake of time, I'm going to focus on these 3 features that we'll be reviewing in the next slide. First is Big Five openness that had the largest contribution among the Big Five measures. The second and the third are the 2 affect regulation strategies used during the study. The first one is how much the participant used distraction as a way to regulate their emotion during the stressors portions of the study. And the third one is how much they use the strategy of reappraisal, which means cognitive reframing of a situation to have a different emotional experience during the study. For the openness, the cutoff value of 33, for distraction, the value of 21, and the reappraisal, the value of 71 was computed. How did we compute these? We computed the feature value corresponding to the largest negative Shapley value and the feature value corresponding to the smallest positive Shapley value. We use the average of these 2 features values as the cutoff value for that feature. We binned reappraisal into low and high categories based on the Shapley values. We found an interaction effect indicating that individuals low on reappraisal category had a drop in anxiety over here when they're in the treatment group, but not in the control group. We saw no anxiety change in the higher reappraisal category. However, notice that people who are better at reappraisal, they had a lower anxiety level anyways as compared to people who are not as proficient in reappraisal. So it seems like there is a main effect of reappraisal in the anxiety level as well that is irrelevant to the use of the device. Honestly, these results reduced my anxiety. I was concerned that I would see that people more skilled in reappraisal would be more likely to benefit from using the device. Such people are already good at regulating affect, and their anxiety is lower as compared to those less skilled, as we see over here. Instead, we saw the opposite and more desirable outcome. The device seemed to help those who really needed the help. Notice that you should be skeptical about this finding because A, we did not pre-register this part of the study. This was an exploratory portion of our work. B, the sample size was not large enough for sophisticated machine learning algorithm like XGBoost that we use to extract the Shapley values cutoffs. We only had 44 participants in the treatment group, but these inferences are valuable because they can ignite insights and hypotheses that we can test in future replications of our experiments. For example, we noticed that children diagnosed with autism spectrum disorder are low on openness and usage of reappraisal. And so we hypothesized that these children may benefit from these vibrations to lower their anxiety. Now we're going to test the efficacy of our approach to facilitate affect regulation in this vulnerable population. As for the use of distraction to regulate anxiety, we did not see an interaction effect that is valid Well, of course, we saw an interaction effect between post-stressor 1 and post-stressor 2 over here, but because we know that this was a mixed design experiment and all participants went through the same procedure till end of post-stressor 1, this result is invalid. On that note, I would like to stop and thank everyone who helped me with this line of research from many disciplines. It takes a city to do a multidisciplinary research, and I'm in debt to each one of you for teaching me something new every day. Thank you very much.